who runs ASPalliance.com, is widely regarded as an expert on scalability and performance, particularly in web applications. And he was kind enough to sit down with me for a few minutes and discuss some of the things that you could do to enhance performance and scalability in the website. So enjoy this.
Where do you work?
Lake Quincy Media.
Lake Quincy Media, what do they do?
We do online advertising for Microsoft developers.
Sweet. And you're a performance expert.
Yeah, I'd like to speak on ASP.NET performance and scalability.
Tell me about your topic today.
Well, tomorrow I'm going to be speaking about just general website performance, so it's not a Microsoft-specific topic, but it's mainly discussing how to improve how quickly a page loads. So it doesn't matter whether that page is being built with ASP.NET or PHP or Java, Ruby, whatever.
Can you share with us a little bit of
Sure.
some of these tips?
Like one of the things that will slow down a page is if it has a lot of external resources, for instance, images, script files, CSS. And by default, most browsers honor the HTTP 1.1 standard that says you can only have 2 connections to a web host concurrently. So what happens is if you've got a page that maybe has 40 or 50 different resources on it, and there's some latency, let's say there's 50 milliseconds of latency between your computer and the server, well, you're going to be able to get 2 requests at a time, which means you're in every 50 milliseconds you're getting 2 of those. So you can basically do, let's say, if I do the math right in my head, you can do 40 requests in a second because you're doing 2 at a time. And that means that your page that has more than 40 items on it is automatically going to take more than a second to load, and that's assuming that all those things take no time to generate.
Right.
Now, if you move like your images or your scripts to a different domain, even if it's a subdomain, so you could have your site is at foo.com and all your images are at images.foo.com and your scripts are at scripts.foo.com. Well, now you've got 2, 3, however many different domains. Each one has 2 different connections to it from the browser. So the browser is going to be able to download 4 things concurrently, or 6 things concurrently, or 8 things concurrently.
Okay.
And it will rapidly speed up how quickly it can download those resources.
By an order of magnitude.
Right.
Potentially doubling that if you have
Sure.
some of the same.
Now you get diminishing returns. Obviously,
Sure.
if you go from 4 to 5, you don't get nearly as much bang for the buck as going from 1 to 2.
Right. Nice. So is this what you do this with your own sites that you created?
Hmm? Yeah, one of the things, Lake Quincy Media is an advertising company, similar like Google AdWords or DoubleClick. And so we have to make sure that the ads serve very, very quickly because we have about 100 requests per second for the ads. And we also want to make sure that they don't impose a performance penalty on the sites that they're being displayed on. So that plus another site that I run is ASPalliance.com. That's a developer article content site. And so it gets a fair bit of traffic and we try and make sure it's pretty quick.
And we were talking about caching as another way of
Sure.
improving performance. What do you use for caching?
Well, there's a bunch of different levels of cache, and one of the things I often talk about in user groups and conferences is about the ASP.NET caching features that are on the server, where you can have a web page be cached, or you can have the data be cached after you fetched it from its source, whether it's a database or a web service or what have you. And one of the easiest ways to improve the performance of an ASP.NET page is to implement caching. And the simplest is just output caching. So, for example, maybe you have a page that is just generating a report and it's used by a lot of users. The data doesn't change all that often. So you don't really need to hit the database every single time to generate this report. If you say that that page is cached, maybe it's cached for 5 seconds even. Doesn't have to be for a long time, so the data won't always be stale. Well, now if that page was being hit a lot, maybe it was the home page on a busy site, you're going to have the performance, the request per second that page can do will just shoot through the roof because that dependency on the database has been removed. And there's a demo that I do pretty often where I just create a simple page that talks to a local database and says like select star from products on Northwood. And I try and maximize how many requests per second I can get just on my local laptop. And usually it maxes out around like 70 some requests per second, and that's just because of my CPU limitations and everything.
And the bottleneck's part of the database there.
And then bottlenecks in the database. And the key thing when you're tuning for performance is that there's always one bottleneck, and that is the only thing that will matter. If you try and tune anything else, it's not going to be effective. So the first thing that you ought to try and do is identify what the bottleneck is, because any optimizations you do anywhere else are just waste. But in this case, I know the bottleneck is pretty much the database. And so by implementing caching, I move the load from the database onto the web server. And typically I go from like 75 requests per second up to 400 requests per second.
Oh, wow.
And I have this running as a live load test, and you can kind of watch the line go along. Then I like save it with the output caching turned on and flip back to the line, and it just goes. Shoo.
And that one little change, you 500% increase in performance.
Yeah. Well, and that's the cool thing about that is I can set the output caching to 100 seconds, or I can set it to 1 second, and it doesn't matter. I get the exact same performance because the database was able to do 75 requests per second. And the lowest I can set the cache to is 1 second, which means the database will be getting 1 request per second. It can do that all day long.
I see.
So, as long as I've made it so the database is doing less than 75 requests per second, it's no longer the bottleneck.
Right. So you said the always find that one bottleneck and work just on that until
Yes.
it stops becoming the bottleneck.
Sure.
How do you know what that one bottleneck is? What tools and what practices do you do that?
That's the trick. A lot of the times in a web-based application, it's going to be the database. But almost any website can get incremental improvements in the page load time to the client by reducing how many network round trips there are and reducing the total size of those round trips. So easy things to do, they're sort of low-hanging fruit, are implement cache headers on your content. So for instance, all your images, all your scripts, if possible, you should set those up with a cache header that says that they never expire. And what that means is that proxy servers and users' browsers will grab that script the first time, and then they'll keep a local copy of it. Or some proxy server between the user and your site will keep a copy of it, so that on subsequent requests, they're not having to go all the way back to your server to fetch it. And what that means is that the browser doesn't have to wait for that request over the network. It just immediately has that file, and it's much faster. Now, the downside to that is that you can't change that content. You have to think of it basically as it's immutable. This file at this location is always going to be this file. And if you need to change it,
the client won't know about it.
correct. So you never ever change it. If you need it to be different, all you need to do is create a new version of it, and you put the version in the file name. So you've got mycoolscript.js, and you just make it mycoolscript 0.1.js. And then when you update it, it's 0.2, and et cetera. And this is all something that you should automate with your build process, so that anytime that script file gets changed, it gets checked into source control, it generates the new script name, and when it deploys out, it's got that new version number built into the name. And then you update all your references so that instead of pointing to the old one, you point to the new one, and then miraculously it now gets pulled down.
I see. So even though point 1 never expires, it doesn't matter. Whatever
Sure.
you use point 1, or use
Correct.
point 2.
And all the sites that used point 1 continue using it. If somebody had that in a page that was using it and worked just fine, you don't have to worry about breaking that page. You can just change the other pages and have that point to the new one.
So you give me an example here of caching between the client and your website, caching things on the client. The previous example was caching things kind of in the middle on the website from the database.
Correct. Yeah, so sometimes it's server side, sometimes it's client side.
And optimally, probably should be both.
Yeah.
Especially if it's something relatively simple to do.
Right. And some of these techniques only really matter if it's a big public-facing site. If you're writing an intranet site and it's like web forms and data entry, well, then you're not going to have to worry about content expiring and things like that. And if you're only going to have like maybe 5 concurrent users on this intranet site, well, then you have different concerns. You're really going to be worried more about the database being fast enough. You're going to be worried about other kinds of performance than if you're writing a large e-commerce site or even just a busy community site.
Or do you bother optimizing if you know you're just building a small intranet site, or do you put some this caching optimization in on the chance that maybe this might become external, might turn into Facebook?
There's a quote that basically, and I can't remember who said it, but it's not me, that premature optimization is the root of all evil. And it's definitely true that 9 times out of 10 when you try and optimize something ahead of time because you know that that's going to be the slow bottleneck, you're wrong. So anytime you spend on optimizations that you don't have hard data backing it up, either that says that it is slow at all or that is the particular bottleneck that needs addressed, is probably a waste of time. And the thing that you have to realize as a developer is that your customers don't care about optimizations of things that aren't the problem or of things that were already good enough.
Sure.
Your customer cares about you delivering new features and fixing bugs. And anytime you spend on optimization, you're robbing them of delivering more value. So what I do is I try and write my code in a smart way. And I know that I might need caching, so I write my code in a way that I can add caching to it if I need to, but I don't do it immediately because it adds complexity. It adds the opportunity for there to be errors. My wife is also my business partner, and she hates caching because for the longest time I was doing caching on all kinds of stuff, and she'd go and do something and she'd say, "Steve, I just changed this and I didn't see the change." I was like, "Oh, it's probably cached." You know, it's like, oh, well, so how do I fix that? Oh, you have to wait 10 minutes for the cache to expire. Well, you know, that's not a very good user experience. And so, you know, these are the kinds of things that, you know, caching has, if you don't implement it correctly, you can have a downside. So you want to make sure that you implement it simply, and then if there's a problem, then you go and investigate. And that's, you know, the customer is the one that should be telling you that, you know, you need to make this faster.
Sure. Late optimization is the key. Wait until it becomes a problem.
Correct.
It becomes a bottleneck.
Yeah, architect it so that you can easily change it.
But what do you mean when you say write your code in such a way that it can be cached more easily?
Well, for instance, one of the things that you might do is you could write your web-based application with you know, certain kinds of data access technologies where just on the page you're directly calling SQL Server with a SQL call, and you've baked all that code into your code behind. And you've done that now on 50 different pages on your site.
So that's bad.
And
right?
now you've got to go and change it. Well, now you've got 50 different places where you might have to change that.
Okay.
Now, if instead, if you had some kind of a data access layer, and all of your requests for these things came in through one API, one interface to that data access layer, if you wanted to somehow wrap caching around that, it would be much easier to do because you have that abstraction. And you can take that even further and you know, use dependency injection and use other things. So that maybe you have a data provider that provides raw access to the database, and now you have another data provider that doesn't know anything about the database, but maybe behind the scenes it could check the cache, and if it's not in the cache, then it could go call the raw provider.
Sure.
And so you can kind of build up this
Build up a
this
caching
abstraction, yeah, with a layer system, so that it becomes easy to add it later if you need it.
Yeah. What do you think about velocity?
Well, Velocity is a distributed cache that Microsoft announced last year at TechEd, and I think it's a little bit overdue. I mean, I'm excited to see that they finally got this because the third-party market has been forced to bring this to market for Microsoft technology for the last 8 years.
Right.
And so now we're finally getting to the point where we've got distributed cache for IIS and for Windows servers. So I've used it, and I think it's pretty cool. I can't wait for it to be in production. We're using a third-party tool from Scale-Out Software for our web, for our ad server right now, and it works great.
Okay.
So it's not something that I'm waiting for because I've already got a solution. But I do think it'll help a lot of customers, and it'll improve Microsoft's offering.
Thanks a lot, Steve Smith.
You bet.
Appreciate it.
Good luck with the interviews.
All right. It's going well so far.
See, that's it. I mean, you're doing a great job, man. Doing better than I am.
I got that on.
That's
I got
good.
that recorded now.
Doing better than I am.
That was John.